Hello. In this lesson, we are going to solve linear systems. We're actually going to be solving planes when there are three linear equations, but it has three different variables in it. So what happens here is that you can have one point where they all intersect, and when we label that point, it would be ordered triple. So you would have an x, y, and a z point. Okay, and that would be right there. Now, in the second example, there's infinitely many solutions. And I'll show you what that means and how to solve that. Okay, so basically every point on this line would be an answer. And then there are situations when there's no solution. Okay, so there's nothing that they have in common for all three of them. And we'll cover that as well. We've already covered two variable equations, and so what we're going to do is we're going to try to get this into two variable equations. So when we solved for x and y before, we're going to do the same thing. We just need to get to two equations that have only two variables so we can use that system. So they label these equation 1, 2, and 3 in the book. I don't like to use 1, 2, and 3 because then there's already numbers in this problem, and so then those numbers get confused. So I label them A, B, and C, and I would like you guys to do the same thing. So when I refer to it, you'll know what I'm talking about. So what we're going to do is we're going to try to get rid of either x or y or z, but we have to do it twice with two different pairs of equations. So just to make it easier for all of us, I'm going to go ahead and get rid of variable x. So first I'm going to use these two equations. So I'm going to have this be 4x, the top one, and I'm going to make the second one be negative 4x. So what that means, I'm going to use equation A exactly how it is. Okay, so equation A. So I'm going to set it up over here. Equation A is 4x plus 2y plus 3z equals 12. Because I'm going to use equation B, I need to multiply this whole thing by negative 2, so that becomes a negative 4x. So again, I have to multiply equation B by negative 2 so that it will cancel with the 4x that's above it. The way that I'm going to write that, and the way I would like you to write that, is put negative 2b here. If you rather put a negative 2 here, that's fine as well. Okay, so when I multiply negative 2 here, I get negative 4x. For the second one, I get positive 6y. For the third term, I get negative 10z, and you have to be really careful. And I put a line through my z so it doesn't look like a 2. And then negative 2 times negative 7, which is positive 14, and then you're going to add these two equations together. The x will cancel, so I have 8y minus 7z equals 26. And I would like you guys to highlight that equation. Now, what we're going to do is we're going to go back to the beginning, and we have to cancel x again. So I can't cancel x again with these two because we've already done that. So my choices are to use these two equations, so 2x and 6x, or to use these two equations, 4x and 6x. So if I'm going to use 4x and 6x, I need to make those 12. If I'm going to use 2x and 6x, I can make those both into 6x. So this one will be easier to use equation B and C. So I'm going to use this equation as it is, which is 6x. And then again, I can't cancel the other variables because I've already canceled x once over here. And so I need to cancel the same variable again. So in order to do that, I'm going to take the B equation and I'm going to multiply it by negative 3 so that it cancels the 6x. So let me draw a line here. And now I'm going to take equation C, exactly how it is. So 6x minus y plus 4z equals negative 3. And I'm going to multiply equation B by negative 2, or negative 3, excuse me. Because that will make that into a negative 6. So I'm multiplying this whole thing by negative 3. So negative 6x plus 9y minus 15z, and don't forget this one, a lot of people forget to multiply that last number, equals 21. Now I'm going to add these two equations together. The x's cancel again, okay, so they cancel here and they cancel here. That's exactly what you want. So I have 8y minus 11z equals 18. So that's my second equation. So now what we have is we have these two new highlighted equations, and what I would like you to do is to think of those as what we learned in the previous lesson, which is to cancel x and y if you're given two equations. So at this point where we're here, I want you to ignore everything else that's on this paper except for those two equations. So you have these two equations and you're starting over. Okay, so I'm going to go ahead and you're lucky in this case because there's an 8y in this one and there's an 8y in this one. So we can actually add those two equations together and the ay will cancel as long as we multiply one of them by -1. So I'm going to go ahead and write both of these two equations over here on the side. So I have 8y minus 7z equals 26. And the second part, I'm going to multiply this one by -1. And so if I multiply that by -1, I will have -8y plus 11z equals -18. And the reason I'm multiplying it by -1 is so that the 8y's can cancel. When I add those two together, I get 4z is equal to 8. So z is equal to 2, and I have my first answer. So this answer will be an ordered triple. Let me erase this stuff up here. An ordered triple is an x, y, z. So I have x, y, and z is 2. So I already know the z answer. Now, we're still ignoring everything else except for the two highlighted equations. So once you have z is equal to 2, that must be plugged in to this one or to this one. It doesn't matter which one you use, okay? So you're either plugging into this equation or that equation. Just to give myself some room, I'm going to take z equals 2 and I'm going to plug it into this equation here. So z is equal to 2 would mean that this would be 8y minus 7 times 2 equals 26. So 8y minus 14 equals 26. If you add 14 over, then 8y is equal to 40. And therefore, y is equal to 5. Let me make sure I leave myself some room here to work. When you're doing this on your paper, you need to make sure you leave yourself some room as well. Okay, so now I have y is equal to 5, and I can put that answer up here as well. So I have two answers. So most of the work is done now. So I've already used the two highlighted equations to find y and z, so I don't need those anymore. So I'm going to take these two answers for y and z, and I could use whichever one of these three equations I want to find x. At this point, I would just pick the one that seems the easiest, where the variables are the smallest. In this case, it doesn't really matter. I'm going to do the work down here because that's where I have the most room. Okay, I'm going to do the work down here, and I'm going to use the equation b. Okay, so if I use equation b, then equation b is 2x, and then it's minus 3y. So if I put a 5 there, that's going to be minus 15. Plus 5z, so if I put a 2 here, so that would be plus 10, equals -7. So this would be 2x minus 5 equals -7. So if I add 5, I would have 2x equals -2, so x equals -1. So that is your final answer. Now, in order to check that answer, if you wanted to, -1, 5, and 2 are the only set of numbers that make all three of these equations true. So if I plug it in here, I would get -4 plus 10. Wait, let me see. Yeah, -4 plus 10 plus 6 equals 12. If I plug it into the second one, I would get negative 2 minus 15 plus 10 equals negative 7, and so on and so forth. So that's the answer to the first question, negative 1, 5, and 2. So again, you want to cancel one variable twice. So we canceled x, and then we canceled x again. I should have actually written here, and I know this is late now, but I'm going here. I multiplied this equation by negative 3 because there will be mistakes, and you need to definitely, so that's negative 3 times equation b, write down and please circle what you're multiplying each equation by to make it so that I can correct it and that you can go back and correct it as well. Okay, so for time's sake, I'm not going to do all the rest of these. You can go ahead and try them, and I'll give you the answers to these. So if you want to check them, do them first, and then you can come back and check them, or you can see maybe where you made a mistake. So for this example, the answer, and we can do these in class, because there's a lot of different ways to do the same question. So the answer for this one is negative 1, 3, negative 4. For the next one, for extra example 1, again, try these ahead of time if you want to know if you're doing them right, and then come back and check your answers. So you should pause the video. 2, 4, negative 3. And for the next ones, I am going to do these because they're slightly different. And you could see when there's no solution and infinite solutions that I want you to know what the work will look like. Okay. So for the first one, the one where it's no solution, I'm going to go ahead and cancel x. And in order to cancel x, I'm going to use these two equations, and I'm going to multiply the top one by negative 5. So what I'll have is negative 5a and b. So b, 5x plus 5y plus 5z equals 3. If I multiply negative 5 times a, that gives me negative 5x minus 5y minus 5z equals negative 10. And if I add these two together, that gives me 0 equals negative 7. So everything cancels, and I get a false statement. If that ever happens, this is no solution. It might not happen on the first try. It might happen on the second or the third. But if at any point while you're doing these, you get where all your variables cancel and you get a false statement, all the variables must cancel. If they all cancel and you get a false statement, then it's no solution. And you don't have to do anything else in that problem. Now, for the next one, it's slightly different. So you'll see what happens here. So again, I'm going to split this up into two because I know that I have to cancel the same variable twice. So I'm going to use equation. I'm going to cancel y in this case. Or we can cancel x, whichever one you prefer. We can do either one. Okay? So I'm going to go ahead and cancel. I'm going to multiply the top equation by, or leave the top equation alone and multiply the bottom equation by negative 1. Okay? So equation A is going to stay equation A, which is x minus y plus z equals negative 3. And then equation B, I'm going to multiply by negative 1, so it just changes the sign of everything. So negative equation B, which is negative x plus y plus z equals 3. So the x's cancel, the y's cancel. The z's do not cancel, so I don't want you to think the z's cancel. So in this case, we have 2z equals 0. So you can solve this problem. You just divide both sides by 2, and z is equal to 0. So we have one answer. Okay, now that I know that z is equal to 0, I actually have an answer here. in the first step. So if you get an answer in the first step, the best thing to do is take that answer and plug it into two equations, but not the one that we just solved. So I'm going to plug in an equation. I'm going to plug in a zero, not into the first two, but into these two. So I'm going to make z equals 0 in those two equations. So I have x minus y equals -3. And I have 5x minus 5y equals -15. Now what I'm going to do is to cancel these, I'm going to multiply this equation by -5. And that will give me -5x plus 5y equals 15. So 0 equals 0. So what that means is that now the x's and the y's cancel, and this is a true statement. And that means that there are infinite solutions. There is a way to figure out what each of those solutions are. For now, we can just leave infinite solutions in class, or just know that it's infinite solutions. In class, I will show you kind of how to figure that out. Z is 0. However, the x and the y are... Actually, we could just do this here. So if I take this part right there and I just solve for y, I could just say we have x and then, or excuse me, if I do, why can't I write? All right, so I have x minus y equals -3. So x equals y minus 3. So I could put y minus 3 here, and I could just put y in that case there. So what I'm doing is I'm just solving this for one of the variables so that they're in terms of one another. So that's one way of doing it. If you just put infinite solutions for right now, that would be sufficient. I think I'm just going to end right there. If we have any questions, we'll go over these in class, and that's it.